feature here is called delay-based scheduling, and you can say this is like kind of become a must feature where it must be enabled, because this is have a very good impact in the voice quality and also in the cell, particularly for the cell edge users, where it can improve the block error rate. Also, the voice quality will improve a lot for the cell edge. So how this feature work actually? Actually, this feature work based on the buffer delay, or you can say that the InnoD will look into the users where it's having in its buffer. So if it's found some users where it's having a high waiting time, for example, the buffer delay for this user is very high based on some values. This might be depend on the vendors itself. So for example, assuming here UE1 having a waiting time more than 30 milliseconds, UE2 have 25 milliseconds. So this will be the priority of the scheduling. So the normal case scenario for the scheduling, you know that we have round robin, you have max over I, and you have this kind of things. If you remember for 4G in general, but in this case we'll use this. This is how the feature will work. It will prioritize the users with high buffer or high waiting time, like instead of the user was having less waiting time. So let's try to simulate this to see how this feature works. Assume this is your scenario. This is the buffer delay of in the input B side. This is the input B side, and here we have UE1. UE1, we assume that the waiting time is more than 30 milliseconds, and we have CQI number 7. So assume here you have 3 packets for user 1, 3 packets for user 2, and 3 packets, for example, for user 4. And this user 1 is edge user, it having a poor radio condition. It can be in downlink or uplink, but I'm just giving an estimation like that to just present that this user is kind of edge user. So if you can see this buffer delay, the arrow here indicates that the buffer delay is very high. So whenever the packet is up here, this means the packet has been waiting for a long time. So how the scheduling will be done for the users? In this case, the input B itself will prioritize the packets with very high delay. So for example, the first packet will be transmitted will be this particular packet. So if you move this one, it will be the first packet to be transmitted to user 1. Again, if you look into the second packet, still having a higher waiting time compared to the others. So if you click in here, also this will be scheduled for the users. Now moving for the second user having this packet, which is also having a higher buffer delay compared to the other users and the other packets. So this again will be scheduled. Here moving for UE4, which will be the same. So to be scheduled, then this one, then we'll have this one, then this one will be moving, and so on. This one, then we'll be ending for that one. So in this case, this is what it will do. It will improve the voice quality because you improve the waiting time, this user having a more faster scheduling, and for sure this will be reflecting from the KPIs point of view. You can see improvement, for example, in block error rate, especially in the uplink, and this is what we have seen before. And even from if you have the MOS drive, you can see also the voice quality will be improving a lot. So let me show you an example from one of the networks. For example, here after enabling the delay-based scheduling, you have seen more than 20% in improvement in the uplink IBLER, and also from the drag test at that time, we have seen improvement in the voice quality.